Hi everyone, this is Miss Janasek, and these are the notes for 6.4, which would be multiplying polynomials. Now, some of what you see today is going to be something you've seen before, and some of it will be a new way to do it. So let's have a look at what our learning target is for this lesson. I can multiply polynomial expressions. Our success criteria. We are going to learn the box method, where we can write the terms of each binomial and multiply them to fill in boxes that will help us. We also have that you can use double distribution method. Also, we need to be able to know how to combine like terms, which is something we've seen before. And can we write that polynomial in standard form, which is what we saw since the beginning of this unit in 6.1. So these are kind of what the two methods look like visually. So let's look at the double distribution first. Box method is wonderful, but most of you at least know regular distribution. And then we can talk about double distribution. So regular distribution, which you've seen, is when we take a number outside the parentheses and multiply it by everything on the inside of the parentheses. So you can see here we're taking the 2 that is out there and multiplying it. So 2 times the 7, or sorry, 2 times the x is 2x, and then that 2 times the 7 as well gives us 14. And then you would combine any terms if there was anything alike. We do not have anything alike because 2x has a variable and 14 does not have a variable. So that would be our final answer. Now let's see what double distribution is like. It's basically meaning we're going to distribute, but we're going to be doing it twice. So looking at this particular problem, we have a binomial. For those of y'all that don't know what a binomial is, it is a two-termed expression like 2x plus 4. 3x minus 7 is another binomial. So we are multiplying a binomial times a binomial. So we take the first term, 2x, and we're going to multiply it by both terms in the second set of parentheses. So 2x times 3x, 2 times 3 is 6, and x times x is x squared. We learned that from our laws of exponents. X times x does give us x squared. Now take that same 2x, but now you have to multiply it to the other term in the second set of parentheses, which is negative 7. So 2x times negative 7 is negative 14x. So that's kind of our overarches that you see, the 2x multiplying to both terms in the second set of parentheses. Now we are going to take the 4, which hasn't been touched yet from the first set of parentheses, and it's going to multiply by both the terms in the second set of parentheses. So 4 times 3x is 12x, and it's positive, so I'm putting a plus. And then that same 4 times the negative 7, which gives us a negative 28. Now notice that each term from the first set of parentheses has been multiplied by both terms in the second set of parentheses. Now the last step to finishing multiplying is to simplify. That means if there's any like terms, we need to combine them. So we learned about that in the beginning of this unit in 6.1 and 6.2. So here we go. We've got some x's here that we can combine. 6x squared remains the same as it is the only x squared. Negative 14x plus 12x is negative 2x. And there is no other constant, so that will come last. Notice our answer is in standard form because the highest exponent, which is the 2, is going first. And then this x has 2x has an exponent of 1, so it goes second, and our constant will always go last. So really, this is distributing, but distributing twice, okay? So let's look at another method to solve this, okay? It's called the box method. So very similar to biology, where you've seen that you can multiply things inside like a box, like the Punnett square, we're going to do something similar. So please note first how to set it up. Draw your box. Since each of our sets of parentheses has 2 terms, x minus 3 is 2 terms, and then 4x minus 5 is 2 terms, that means we want a 2 by 2 box, creating 4 squares. Okay, So x minus 3, you'll notice I put along the top. Okay, you could put x minus 3 on the side. It doesn't matter which one goes on top and which one goes on the side. And then we've got 4x minus 5 on the side here. Notice that the 5 has the negative or the minus in front of it. That is very important. If you have any questions about how to set this up, pause the video and raise your hand to ask for teacher assistance. Now from here, you can read on the right what to do for step 2, which is to multiply the rows by the columns to get each box. So for instance, to get my first box in the upper left-hand corner, I'd multiply 4x and x to get 4x squared. And then to get the box to the right of it, we take that same 4x, but we're multiplying it by negative 3 now to get negative 12x. Now I'm going to take that negative 5 right here, and it's going to multiply by both the x and the negative 3 to get those final two boxes. So negative 5 times x is negative 5x, and negative 3 times negative 5 will give us a positive 15. You can put the plus if you want, but you do not have to. Okay, so now let's go ahead and write our final answer. So we take each of those and we're going to put all those pieces and write the final answer, the polynomial. So you'll notice that 4x squared is the only x squared in those four boxes. So it will remain exactly as it is. Notice that I'm putting it first because we want it in standard form, biggest exponent first. And then look diagonally there, guys. Our x's are diagonal from each other. And we need to combine them because they are like terms. So negative 5x plus negative 12x is negative 17x. And the last thing that you should put is your constant, and it's the only one there, which is positive 15. That is our final answer, and notice that it is in standard form. Now let's look at both of these methods. They both do the same thing, okay? When we're doing double distribution, you are multiplying and getting 4 different terms. And we do the same thing with the box method. We get 4 different terms. And then when we work diagonally, we're combining like terms just like we were in the double distribution when we circled the like terms. So these processes give us the same result. So none of your teachers will mind if you prefer one method to the other. So if you like double distribution, use that method. If you prefer box method, use that method. We are totally happy with whichever method you choose, okay? If you have any questions about these notes, raise your hand and your teacher will come help. Thanks, guys. Have a great day.